So thank you all for attending my talk. My name is Dan Graham. Just a brief introduction. I am a software engineer at Sauce Labs, and I've been at Sauce Labs coming up on 6 years now. My experience with Android comes from having worked for over 2 years on the Appium project. So I have some experience with Android automation, including Espresso, which will come up in this talk. Vincent Lussenburg is a product manager at Backtrace. He was originally supposed to be here to co-present with us, but unfortunately, he is on COVID protocol right now, and he will present via a pre-recorded video. So the title of the talk is How to Crash Your App in Production and Still Delight Users. So it's a bit of a provocative title because it seems like an oxymoron to say that you can crash your app in production and still make users happy. I mean, nobody's delighted by apps crashing. You may think an app should never crash in production and we should just focus our efforts entirely on how to ship an application that doesn't crash at all. But as we all know, despite our best efforts, errors and crashes are going to slip through and make their way into production. If we want to keep our users happy and have our users keep giving us the all-important 5-star reviews for our apps, we need to have strategies for how to deal with production errors and fix them quickly. So on the agenda today, we will talk about 3 such strategies. First, we'll talk about how to catch errors in production. Second, we'll talk about how to reproduce and troubleshoot those errors. And third, we'll talk about how to make sure that the errors never happen again. So the first step to responding to an error in production quickly is to know right away when an error has happened. If your app has crashed in production, you need to know that it has crashed before you can respond to it. And how do you know that it's crashed? Do you wait for your users to email you, or do you wait for them to send angry tweets to your company Twitter account? Well, ideally, we'd like to know sooner than that. And for, excuse me, and for information on that, I will pass it off to Vincent, who will be giving us a pre-recorded demonstration.
Hello, this is Vincent Lussenburg with Sauce Labs' Backtrace product. I'm a product manager here. What I will quickly show you is 3 things. How to capture errors, hangs, and crashes so they show up in this environment that you're seeing, how to prioritize based on all the data that's available in this environment, and how to resolve your problems by seeing all the metadata that we capture. Without further ado, let's immediately go to Android Studio. What is required to integrate Backtrace to have your errors, hangs, and crashes show up in that central environment? You import our library and you add initialization code. So this code is of course listed on our integration page. The only thing that's really unique is the URL to use specific environment, which you find under your project settings. That's all that's really required. So the moment that I build an APK, errors that happen will be reported to Backtrace. Of course, I already pre-built that APK. I have it right here. So let's go ahead and I will launch that on one of the devices that I have available to me. What this will do is start up the device, a cleaned up device, and launch that APK like you see. In this case, I'll simply crash it by clicking the bike light. That's basically where we've embedded a crash. And I'll end the session. And what I will see is that there's a live result. So it still has to, now it's completed. And what it will show me is under error and crash reporting that it detected an error. So I can click this and it will take me straight to the error that happened on this specific device, which in this case is when I clicked that bike light. So that's the capture part. You clearly see that the errors are being captured there. Again, native crashes and hangs will be captured as well. Let's take a look at how to prioritize. How does Backtrace allows you to prioritize? So first of all, making sure you have a lot of signal and not noise, like a high signal to noise ratio. We showcase your error-free users, so the ability to give that information when the application starts up. That session was started. And I'll fly through this. We deduplicate the data. So that basically means that we analyze the crashes so that you don't have to. So for example, we see 1,500 errors that are all the same. So they happen on different devices, but we duplicate them for you. So that helps you to prioritize by seeing, okay, what error is affecting most of my users? How many errors are that? We allow you to drill down even deeper. So what I have an overview is here is group by application version. It's clear that my 2.1.0 version has a problem. It has a lot more errors and a lot of more users are affected. And I can pull all kinds of information in. So I can do a comparison between Android versus iOS. In this case, it's a multi-platform app. And I can see as well where the app crashed. And I clearly see in this 2.1.0 version, it crashes all the way in the beginning where the other errors are all through the app. In this case, what I took a look at as well is which host names that this individual problem occurred, which you see that is obfuscated, but it still relates to a unique device. And I see actually, this is like what, 10 to 12 devices that specifically have this problem. I can pull in other information if I, for example, would be interested in device model or something like that. That's information that I can collect quite easily as well. So this greatly helps you to prioritize based on seeing how many users are affected, what devices, when, and that can all be very important information to prioritize one problem over another. In this case, the takeaway could be that I don't really necessarily have to fix a problem. I might want these users to upgrade to a newer version, for example, right? So we've seen capture through the SDK. Now we've seen how to prioritize this. How do we resolve problems? So what Backtrace focuses on to give you a lot of information on that you have everything you need to resolve the problem. So this is an iOS version. That's not why we're here. So let's go ahead and select an Android one, and I'll do the one from the last hour. So we see the problem that just happened that I live demoed. So what we clearly see here is where in my application that this can be linked to your Git repository as well. I'll skip that now for time reasons. A lot of metadata on the types of devices, your memory, battery level, network status, and stuff like that you have info on that. Breadcrumbs that capture information on what did the system and the user do leading up to this problem. So you can see exactly what flow they followed to get to this specific problem. You have the ability to include attachments for all these error types. So for hangs, errors, and crashes, you can include attachment log files, stuff like that. So this makes sure that you have everything here, that your developer can look at that, locate in the source code what the problem is, and without having an additional interaction, having to ask the user and being able to immediately fix that. It's not always the case. Sometimes you do want to reproduce it because it might be a memory issue, in which case the breadcrumbs can be really helpful to find out how the user got to that individual state. The summary, I've showed you how to capture by embedding our SDK, how to prioritize by parsing through that data where you have a lot of signal, not a lot of noise. And finally, I've shown you how to resolve that by taking information on all the data and metadata that Backtrace captured. Thank you very much.
Thank you, Vincent. All right, so now that Vincent has covered how to catch errors in production, the question now is how can we fix errors and ship the fixes into production quickly to keep our users happy? So with what Vincent just demonstrated with Backtrace, we can make use of debugging metadata and stack traces to narrow down the root cause of the error. If you're lucky, you won't even have to reproduce the error on a device. The debugging metadata may give you enough information to write a fix and ship it without needing to reproduce the error. However, if you're not so lucky, you may need to reproduce the error on a physical Android device. If you're even more unlucky, the device you need to reproduce the error on may not be available to you. So this is where Sauce Labs comes in. With Sauce Labs, we have a grid of real Android devices available to our users. There are 179 of them in total. We have Google Pixels, Samsung Galaxies, Amazon phones, LG, Sony, HTC, and many others. Using Sauce Labs live testing, in just a few steps, you can take your APK, upload it to our cloud, and then start a live session with your app in any of the aforementioned real devices and troubleshoot your errors. And to clarify, when I say real device, I literally mean that they're real physical devices. These are devices that are sitting in our data centers that are ready to be used by our users. So let me demonstrate it for you now. So here's a screen recording of me uploading an APK to Sauce Labs and then running the app remotely on a Google Pixel device. So I log into Sauce Labs and I go to Live Test Mobile Apps and I upload my APK from there. Once it's done uploading, it'll show up in the list of apps, and I can select a device to launch the app with. So I'm going to select Google Pixel 2. Okay, so now the real device is now being prepared for me, and now it's installing the app. So this takes about 10 seconds. When it finishes installing, I can control the device remotely through my browser. Right. So now I can control the test, or I can control the application and control the device, and I can troubleshoot any errors that might have made its way through production. So this here is just our demonstration app. So this is just a sample e-commerce app that we use for demonstration purposes. Okay, and then when we're finished running, you hit end. And then you can look in the test results page, and you can view the test that you just completed running. And from here, you could view a video and logs of your session. Okay. All right, so now that we know how to catch errors, reproduce them, fix them, and ship them, we can now breathe a sigh of relief. Errors that make it into production can be discovered and fixed quickly, making our users happy. Now, how do we keep our users happy? Well, one certain way to make sure the users will be unhappy is if you allow the same errors and crashes to keep happening over and over again. So how do we make sure that the errors that we fix don't come back? The answer is regression testing. The cheapest and most efficient way to regression test an error is, of course, to write a unit test. So if you can regression test the error with a JUnit test and something like Mockito, that's perfect. But a unit test may not always suffice. The error may not be reproducible as a unit test. You may need to add a new test case to your Espresso end-to-end test, or update an existing test case that reproduces the error and proves that the error is gone. But now we may have the same problem as we had before with manual testing. If the error only happens on a certain kind of device, then the automated regression test will only do its job if it's run on the kind of device that had the problem in the first place. So what we need is the ability to take our automated tests and run them on a bunch of different kinds of Android devices. With the Sauce Labs Real Device Cloud, we have the ability to run these tests on a bunch of different devices and run them in parallel for improved performance. In this next demonstration, I'll show you how, with a simple configuration in YAML, you can make your Espresso test run on a set of devices in parallel on the cloud. So to run the tests in the cloud, you need to configure a YAML file which specifies the apps to test, so both the Android app and the test APK, and specifies a list of devices you wish to run your tests on. So using our command line interface called saucectl, you can then run the tests in parallel in our cloud. So there it's just going to run saucectl run. And then I'm going to go back to the application and I'm going to view the tests as they're in progress. So I log back in. And now I can watch my espresso tests as they're in progress. Right, so 2 of the tests are in progress right now, and 1 of them has completed. So while the test is in progress, you can watch it. You can watch it running. And when a test is completed, you can view the test results. So you can look at a video of your test, the test cases, metadata, and logs. So including logcat logs and device logs. Okay, so as you can see, by making use of automated UI testing with Espresso, we can test fixes for our errors and run those errors on a variety of devices to ensure that the errors do not return. And so to learn more about that, you can register an account for free and view the Espresso Getting Started guide. Okay, so that actually concludes our short presentation. We have a few minutes to spare. Thank you all.